My dear students, now I am going to explain mechanical properties of solids. So small chapter, one question compulsory. So complete this chapter, Young's modulus related questions and strain energy per unit volume related questions and compressibility bulk modulus related questions only. Till now questions asked. Very small chapter. So different model questions, please concentrate students. Very first question here. There is no change in volume of wire due to change in length on stretching. Poisson's ratio of material. Very, very important. Relation between volume strain, longitudinal strain and Poisson's ratio. Please remember students, delta V by V equal to delta L by L into 1 minus 2 sigma. This is the relation between volume strain, longitudinal strain and Poisson's ratio. Here it is given, there is no change in volume. That means delta V by V equal to 0 given in the question. So delta V by V 0 is nothing but delta L by L also cross multiplication, it is 0. So that means 1 minus 2 sigma equal to 0. So 1 equal to 2 sigma, sigma equal to 1 by 2. So delta V by V equal to 0. What is Poisson's ratio asked? So what is the value of Poisson's ratio? 1 by 2. It is given first option 0.5. Okay. So this formula related 2 times asked question. Students, very, very important. Previous NEET asked the same model question. Yes. The second question, I told strain energy related question also important. Second question, elastic energy stored per unit volume. So energy stored per unit volume is half into stress into strain, students. I think you know formula, many students you know very well. So but directly not given here in terms of Young's modulus given. You know Young's modulus y equal to stress by strain. So that means here stress equal to, from here stress equal to y into strain. So stress equal to y into strain, substitute here. So strain energy per unit volume equal to half into stress is nothing but Young's modulus y into strain, already one strain. So strain into strain is nothing but strain square. So half into y into strain square. This is energy per unit volume. First option only given, students. So three different formulas, please remember. Half into stress into strain, one formula. Half into y into strain square, one formula. So half into y by stress square also. Stress square by 2y. Stress square by 2 into y also, one more formula in terms of stress and Young's modulus. So now here first option is correct, students. Next question. Two wires of same material and radius have their lengths 4 is to 3. So ratio of two wires is given, length ratio L1 is to L2 equal to 4 is to 3, 4 by 3. If these wires stretched by same force, very important, students, stretching by same force, strain produced in the two wires, Young's modulus y equal to stress by strain. So strain produced, asking here, strain equal to stress by y. Stretched by same force is given, that means stress is same only. And Young's modulus made up of same material given. Young's modulus made up of same material means Young's modulus also same. So what is the ratio of strain? Strain ratio 1 is to 1. Many students here confusion. So length 4 is to 3 is nothing but strain also increasing length to original length, like that thinking. No, students, here strain is 1 is to 1 only. Stretched by same force is given and material also same given, students. Now 1 is to 1, very important. Next question. Young's modulus of a wire of length is L, diameter is D is Y. If length of the wire is increased 3L by 2, then Young's modulus. One more important, many times repeated question, it is also Young's modulus Y equal to FL by A into E. Very important, students. Young's modulus does not depends on force, does not depends on length, does not depends on area, does not depends on elongation. Young's modulus depends only nature of the material. Nature of material. So Young's modulus of wire increased 3L by 2, same wire only. Same wire is nothing but what about Young's modulus, students? As length increases, decreases, Young's modulus does not change, students. Young's modulus of material becomes same only. Don't confuse again. So this is also many times repeated question. But here elongation, students. Elongation E equal to FL by A into Y. So elongation is directly proportional to force. Elongation is directly proportional to length. Elongation is inversely proportional to area of cross section by R square, diameter square. And elongation is inversely proportional to Young's modulus. So elongation depends on 4 physical quantities, but Young's modulus does not depend on any other physical quantity here. It depends only nature of the material. So wire same means Young's modulus also same. Yes, students, I think everyone got this point. Next question. So wire area of cross section 10 power minus 2 centimeter square is increased length by 0.2%. When tension in the string 1000 newtons is produced, then Young's modulus of the wire. So formula based question, students. Young's modulus Y equal to FL by A into E. I told in this chapter Young's modulus related questions only, very important. Yes. Now here Young's modulus Y equal to F force is given 1000 newtons, students. 1000. Length is directly not given. Increasing length is given. Okay. So area of cross section 10 power minus 2 centimeter square, 10 power minus 2 into 10 power minus 4 meter square, and 0.2 elongation per unit length. So that means E by L direct given here 0.2 percentage. So 0.2 by 100. Okay. So now simplification only. Y equal to 1000 here, 100 here, 10 to the power of 5 by 10 power of minus 6 here. 0.2 is nothing but 2 by 10. Okay. So now here 2, 5. So 5 into 10 power 5, 10 power minus 6 is nothing but 10 power of 11. So 5 into 10 power of 11 given third option, students. 5 into 10 power 11 for this question. Clear? Direct formula based question, simplification. Yes, students. Next question. Approximate depth of ocean 3000 meters. Compressibility of water, I told. Next, compressibility also previously NEET 2 times asked question. Compressibility means reciprocal of bulk modulus. You know bulk modulus B equal to change in bulk modulus is nothing but volume stress to volume strain. Volume stress bulk modulus related pressure P, change in pressure by change in volume delta V by V, students. So this is bulk modulus. Compressibility means reciprocal. Compressibility C equal to 1 by bulk modulus. Now formula is reverse delta V by V by delta P. So here compressibility C value is given, okay, and rho GH height is given, density also given, fractional compression of water bottom of ocean. That means this delta V by V is asking, students, fractional compression. So delta V by V equal to compressibility into delta P. Delta P, d depth is nothing but rho GH. So delta P is nothing but pressure inside. So actually fluids related concept, pressure inside is, you know very well, rho GH. So C into rho GH, just value substitution. So C compressibility given 45 into 10 power of minus 11. G acceleration due to gravity, density 10 power of 3, acceleration due to gravity 10, height is given 3000 meters. So that means 3 into 10 power of 3. So 45 into 3, 135. Now here 135 related second option is given. After simplification, students, you will get option second 1.35 into 10 power minus 2. So normal simplification only. 45 into 3 is 135. 135 related, here second option only given. After simplification you will get 1.35 into 10 power minus 2. Clear, students? So fractional compression of water 1.35 into 10 power of minus 2. No unit, students. Change in volume to original volume. Yes. So these model questions also important. Again I am saying, students, Mechanical properties of solids, Young's modulus related questions, compressibility related questions, strain energy per unit volume, energy related questions only. Very, very important. Yes. Next question. A wire of length is L, diameter is D, breaks when it is stretched with force is F. At what force? Another wire, same material but length is 2L and diameter is 2D will break. Breaking stress. Breaking stress is nothing but force per unit area. So this is constant only, students. Given condition, this is constant. So F1 by A1 equal to F2 by A2. Here length is doubled given, but breaking stress, students, very first point, breaking stress does not depends on length. Breaking stress depends on what? Area of cross section means radius and diameter. So diameter 2D is given, length double is given, but length double also breaking stress does not depends on length of the wire. Very important. Note this point, students. I told whenever I am stretching, that point is very important. Now here F1 is, F is given, area of cross section A. F2 is asking here, by area of cross section diameter doubled. Diameter doubled is nothing but R square is nothing but 4 times. Area of cross section 4 times more. Simple only. Now here area of cross section, area cancel here. F2 equal to new force equal to 4 times of F. Given option 4, students. 4F. Okay. Please note down, important. Next. Students, actually this fluids related question, students. Here came here. Fluids related question. 30% volume of floating cubical block is outside the water, then relative density of block. Listen. So for example here 30% floating, students. 30% floating is nothing but 70% inside the water. You know, weight of the block partially immersed or completely immersed equal to weight of the fluid displaced. Archimedes principle, you know very well. So weight of the block partially immersed or fully immersed, block related weight is nothing but mass is density into volume. Density of block rho, volume of block V, G. So this is weight of the block which is immersed inside a liquid equal to weight of the fluid displaced. Weight of the fluid displaced means fluid related density is rho W, water here. And volume, listen careful, students. Volume is 30% floating means 70% sinking. So that means 70% means 0.7 V volume inside the water. So this much volume only liquid displaced. So delta water, that means density of water, volume 0.7 into V into acceleration due to gravity G. This point important, students, please note. Weight of the block completely immersed or partially immersed, weight of the block which is immersed inside a liquid equal to weight of the liquid displaced, Archimedes principle. Yes. So now here V is cancelled. Question is asking relative density. Relative density means density of block to density of water. This ratio only asking. So G cancel only, 0.7 only answer. So 30% floating is nothing but 0.7. Fourth option is correct. Relative density is 0.7. Very important, students. These model questions, Archimedes principle, very important. Next, two wires of same material and same area of cross section have length ratio 2:3. L1 by L2 equal to given 2:3. Then under the effect of same stretching force is same only, respective elongation E equal to FL by A into Y, students. Two wires same material given, that means Y same, okay, and same area of cross section, area same, length 2:3, okay, under the effect of same stretching force also same. So elongation is directly proportional to length only. So E1 by E2 equal to L1 by L2. L1 by L2 already given 2:3. So what is the ratio of elongations means elongations also 2:3. Okay, students. Now answer here 2:3. Next, longitudinal strain is meaningful in case of solids only. Longitudinal strain in case of liquids and gases not possible, students. In case of only solids, tangential stress. Tangential stress, it is in case of only solids. Steel is more elastic than rubber. NCERT question, many times question. Steel is more elastic than rubber. Yes, why? Because Young's modulus of steel is more than rubber. So steel is more elastic than rubber. Correct only. Up to proportionality limit, Hooke's law is applicable. Yes, Hooke's law only. Within the elastic limit, applied stress is directly proportional to strain. Within the elastic limit, stress is directly proportional to strain. That is only given here. Up to proportionality limit, Hooke's law is applicable. Correct statement, students. So both statement A and statement B both are correct. Option 1 is correct. No doubt. Next, students. The following 4 wires are made up of same material. Which of these will have largest extension when the same tension is applied? These model questions also 2-3 times asked. So Young's modulus y equal to FL by A into E. Elongation E equal to FL by A into Y. So 4 wires made up of same material given, Young's modulus is same. Okay. Which of these largest extension, elongation? So for different lengths given, different areas given, students. That means elongation is directly proportional to length area of cross section pi r square. Okay. So that means pi is constant only. Elongation is directly proportional to length, inversely proportional to r square. So just which is more, from here you can easily calculate. Length here, length is 50 centimeter given. So all units the same only, students, no need of conversion here. Here centimeters, here millimeters given, no need conversion. So 50 by 2 square, 4 here. Here 100 by 1 square, okay. Here 200 by 2 square, 4. Here 300 by 3 square, 9. Just you see, students, from here. This is 12.5. This is 100. 100 only more, second is more. 200 by 4, second only more. 300 by 9, second only more. So which case more extension is nothing but more elongation, largest extension is in case of second wire. Options verification. No other possibility, students. Options verification only method. Correct. Easy. Okay, students. Very important. For example, same question. For example, increasing order or minimum. Minimum which case is nothing but here it is. So 200 by 4, 50, 300 by 9. Less only here. 12.5. Minimum is first wire only, students. 12.5. Yes. Now next question. This is also important, students. Now the length of material wire L1 when the tension in the string is T1. So wire, one particular instant, tension in the string is T1, length of the wire is L1. So that means original length, let us consider L0. So difference, students, difference in length here. L1 minus L0 extension is directly proportional to tension. More tensional force means more elongation. You know very well. Second case, when the tension is T2, length is L2. So second case length is L2 with respect to initial T0, applying force is T2, students. So question is asking what is unstretched length. That means L0 is how much? Okay, students. Let us consider this first equation, this second equation. So L1 minus L0 by L2 minus L0 equal to T1 minus T2. Just cross multiplication. T2 L1 minus T2 L0 equal to T1 L2 minus T1 L0. So now here T2 minus T1. So this term take this side, T1 minus L2 take left side. That means T2 L1 minus T1 L2 equal to T2 L0 minus T1 L0. So here L0 common, T2 minus T1. So T2 L1 minus T1 L2. So L1 T2 minus L2 T1, given third option, students. Just you see careful. So here, so L1 T2 minus L2 T1 by T2 minus T1. See here, T2 minus T1 is L0. L0 is nothing but original length, initial length. Initial length only, unstretched length, students. Okay. So sometimes formula based question only, sometimes length of the wire 5 centimeter, tension in the string is 20 newtons. Length of the wire, like that questions also. These formula related questions also they will ask students. Okay, important. Next, Young's modulus of the material of wire is numerically equal to. See how many questions, students? Same model questions only. Young's modulus Y equal to stress by strain. Young's modulus numerically equal to stress when, students? Strain equal to 1 unit. So if strain is 1 unit, Young's modulus numerically equal to stress. Just a definition. Stress required to produce unit strain. Second option is correct, students. Okay, important. Next question. A uniform cylindrical rod of length is L, cross sectional area A, Young's modulus is Y, is acted upon by forces. Yes, equilibrium condition, students. So now I am splitting here rod divided two parts. First rod, students, this part rod, the second part of the rod. So here force given in the question 3F. For every action there is equal and opposite reaction, must be here 3F only, students. Any doubt, check here. Here F force right side means must be here 2F right side. Here 2F right side, students. So 2F, F, 3F right side here. So here 2F right side is nothing but must be equilibrium condition 2F left side also. So this 2F balancing here, this 3F and complete this 3F balancing here. So 3F and 3F, length of this part is L by 3 given. Length of this part L by 3 is nothing but what about length, students, here? 2L by 3. 2L by length here, L by 3 length here. Okay. And here force is 2F and also force is 2F only. So here 3F force is acting, here 2F force is acting. Because of 3F force elongation, let us consider x1 here. Because of 2F force elongation here, x2. What is total elongation of the rod asking? These model questions also important. So total elongation x equal to x1 plus x2. You know elongation E equal to FL by A into Y. So first wire, students, first wire elongation, force 3F, length is 2L by 3, area of cross section A, Young's modulus Y, plus second wire force is 2F, length is L by 3 by area of cross section A into Y. So A into Y here common. Okay, 3 into 2, 6 FL by 3. Here 2 FL by 3. That means 8 FL by 3. Just addition only, students, normal addition. 8 FL by 3 into AY. So this is given fourth option. Clear, students? So very important model. These model questions also asking, students. So this is about mechanical properties of solids. So please practice these different model questions for coming whatever entrance exams. Okay, students? Thank you. If you are really liking the video, please share and subscribe my channel, students. It is very little happy thing, students. Okay, thank you, students. Thank you so much.